As you have probably noticed in the various tessellations that we've seen and that you've created, there's a lot of patterns to be found in tessellations. And some of these patterns we refer to as symmetries. So what is symmetry? A symmetry is when you are able to do some fairly simple movement in order to make a shape or object occupy the exact same space as it did before the movement. So some examples of simple movements are translations, which is like sliding a figure into a new spot, rotations, which is just like it sounds, rotating the figure, or reflecting, which is like flipping a figure. So there are symmetries in tessellations which are using these simple movements in order to make the tessellation occupy the exact same space as it did before. So there are 4 different types of symmetries that we can find in these tessellations. One is a translation symmetry. So take this image for example. If we slide this image into a new spot, you can see that this tessellation lines up exactly with itself. And remember, tessellations are meant to be infinite. So even though we've moved this image into a new spot, if the tessellation continued infinitely, the shapes themselves would still occupy the exact same space as they did before. We can also have rotational symmetry. So if we were to pick a point on this image here and rotate it around that point, we would be able to rotate this picture, this tessellation, so that it still occupied the exact same space as it did before, like a point here. So if we rotate that, you can see that the shapes all line up with the exact same spots as they were before, but the colors don't match up. But that's okay. So when we're looking for symmetries in a tessellation, we don't care that the colors of each shape all line up, only that the space that the shapes occupy is exactly the same. We can also have reflectional symmetry. So with this image here, we can pick a line like this one and flip the image along that line, meaning that the points that are on that line are all going to stay where they were before. So we flip the image like this. And notice the shapes in the image are still occupying the same space as they did before. But we said that there were 4 types of symmetries, and this is only 3. So there's a 4th kind of symmetry with tessellations called glide symmetry. A glide is a combination of a reflection with a translation. So let's look at this with an example, like this image here. So let's say we were going to reflect it along this line. We'll put a copy of this image over here so that we can see what happens. So if we were to reflect it or flip it along that line, we would get this. This image looks very similar to what we had before, but notice that the birds are facing the opposite directions now. So they're not occupying the exact same space as it was before. But we can notice that the bird head in our reflected image does match the direction of the bird in the next row below. So we could slide this image down so that those would now line up. So now the image with this reflection and translation would occupy the same space as it did before. And we can see that if we put a copy of this glided image over here. Now before we leave you with your task, it's nearly impossible to talk about tessellations without bringing up M.C. Escher, a famous artist. Escher brought the mathematics of tessellations into the world of art. He literally sought out mathematicians to learn the geometry of tessellations after being inspired by some beautiful geometric tilings in a palace in Spain. As you can see, tessellations then became a central part of most of his artistic work, and he even started to experiment with various other ways of thinking of tessellation, like in this last picture here. So your task is going to be to identify some symmetries in M.C. Escher works. So in these 5 M.C. Escher works below, you want to identify which of these 4 kinds of symmetries apply to each of these images. So determine whether they have translational symmetry, rotational symmetry, reflection symmetry, or glide symmetry. And notice that these pieces can and will have more than one of these symmetries, so try to find all of them for each. So for example, one of these images might have both translational symmetry and rotational symmetry, so you would list both of those for that image.